In use case 1, the idea of mobility microincentives was utilized. For this pilot, in the city of Brussels, we selected some specific areas in which public transport is not completely available. Discounts were given to users using bicycles and kick scooters from DOT. Whenever they initiated a trip from one of these areas, they got a discount. With this pilot, we proved the idea that mobility microincentives can encourage or can nudge mobility behavior towards more sustainable choices of mobility. Use case 2 was led by Keita Mobility Factory. Using lane patrol, an assessment of the cycling infrastructure safety was performed in the city of Barcelona. This solution comprises both hardware and software. The hardware is a solution that collects georeference images to then use them in the software to analyze the safety of the cycling infrastructure. In this pilot, just like other pilots in the Molière project, having accurate positioning thanks to Galileo was relevant to validate the initiatives.
For demo purposes, we've built Mobility as a Service app that showcases how you can discover, combine, book and pay for mobility services from a variety of providers that are connected to the data marketplace. One of the use cases we have developed is the use of the governance token as a mechanism to incentivize the early growth of the platform. Taking a car-sharing fleet as a reference, we match the data coming from the provider with the data coming from hardware sensors deployed in the cars.
The Nemes use case is about 3 main points. First of them, sharing our authenticated Galileo data with the Molière data space. For the second point, we will be creating a cross-validation tool between our theoretical routes and our actual driven routes. This will prove the number of registered positions by Galileo against other receivers. And for the third point, and related to the second, this tool will also be capable of justifying the number of actual driven kilometers by our buses.
Our use case focuses on public transportation with buses, with a view to assess the potentialities of accurate geopositioning systems in a bus line. The goal is to infer kinematic variables such as acceleration, velocities, and then use them to estimate energy consumption in buses.